Are there any shortcomings? Are there any weaknesses? Are there any cons that you see that despite Kubernetes awesome capabilities for operators, users are not able to get the most value out of their cloud investment? Hi, this is your host Apnil Bhartiya and welcome to TF4 Let's Talk. Today we have with us once again Elad Ben-Israel, CEO and co-founder of Wing. Elad, it's great to have you on the show.
Hey, how are you, man? It's good to see you.
It's my pleasure to host you here again today. And let's talk about Kubernetes, the adoption that we saw. Almost everybody is using Kubernetes. A joke also, right? Just the way there was a joke about cloud, everybody's using Kubernetes. What is your assessment of this hype? Do you see that Kubernetes is worth this hype?
I think sometimes it's worth it and sometimes it doesn't. And I think the hype because of the hype, we ended up in a situation where many people are using Kubernetes or buying into or committing into a Kubernetes journey without the right justifications. For example, we just talked to this customer, a couple of weeks ago, and they're running on AWS. They're using serverless technologies. They're happy. They have like a very effective team, but their external DevOps engineer is pressing them to move to Kubernetes. And it was really interesting for me to meet this team in this particular time, because this is a decision point, right? And they will need to make a decision whether they're moving to Kubernetes or not. And it was interesting to see the way they're thinking about it. One aspect of this was that they don't understand what Kubernetes is. And so they don't have DevOps capability, expertise in their team. They have like this external person advising them and helping them. And this external person is the person who's pushing them to use Kubernetes. So one data point. The second data point was that I asked them, okay, so why do you want to move to Kubernetes? And their answer was that they said, I think eventually we will probably want to run on other cloud providers. And that was really interesting to me, because I felt it's kind of like the default answer for many people, that kind of like the excuse that people tell themselves why they are using Kubernetes. I've heard that a lot. And I would argue that's actually not a good reason to use Kubernetes. Because eventually orchestrating a bunch of containers, especially if you're building a really complex, highly scalable system with states, complex state, and you have to manage replicas of state across, right? Those are things that Kubernetes can do very well. But most of the people that I've ever talked to that use Kubernetes, they basically run a bunch of HTTP servers on their Kubernetes cluster, right? They basically use Kubernetes to take an HTTP server and make sure that it can scale to a certain capacity. That's the main use case. And I think to do this, not only you don't need Kubernetes, I don't even think you need containers, right? I think you can, or you even need a container orchestration system. You can do this with VMs. We've been doing this with VMs since, the dawn of the cloud. We can create a fleet of VMs with an auto scaling group, a bunch of monitors on CPU and memory. And, I've seen hundreds of systems that work like that and can scale to an infinite amount of capacity. And I think thinking about Kubernetes as a way to be able to port your application across cloud providers is funny to me, because you can also do this with VMs, right? You can also take your Java application or your .NET application or your Node.js application and run it in a scalable VM fleet across every cloud provider. And in a sense, Kubernetes' usage of the cloud is basically VMs, right? That's the lowest common denominator. That's why Kubernetes is so prevalent, because it just needs a bunch of VMs, right, to work. And so I think that's a really interesting answer. I would say the best answer to this question of why would I move to Kubernetes, it would be the ecosystem. The ecosystem that's building around Kubernetes, right? Because if you're not using Kubernetes, then there are many tools that you can't really use, right? Like there are many tools today that are only running on Kubernetes. And so I think that's a pretty good answer, because if you want to be able to use all these tools, then you probably need to be able to maintain a Kubernetes cluster. But again, we see the industry. Many of those tools exist on cloud providers, and many of these tools exist as SaaS offerings. And so I don't know. It's an interesting example.
Are there any shortcomings? Are there any weaknesses? Are there any cons that you see that despite Kubernetes awesome capabilities for operators, users are not able to get the most value out of their cloud investment?
There are two aspects to this. One is committing to maintaining a Kubernetes cluster is a huge commitment. And I think teams don't realize that before it's too late in many cases, because getting started is not too hard. But as your system evolves and as requirements grow, and as the cluster kind of gets bigger and more complex, maintaining this is a lot of work, and it's completely non-differentiating, right? Like it's not, in most cases, almost all cases, that's not part of your business, right? Like that's not part of what you're trying to do for your customers. You're basically maintaining this cluster because you need to serve your customer. You need more, you need more scalability. You need more regions. You need more types of operators installed on your cluster, and you need to maintain them. And so there's a accumulating maintenance cost for this cluster that is it's a pretty big investment that's hard to quantify initially. And I think in most cases people have to maintain more than one cluster. Like people maintain production clusters and staging clusters and development clusters, and each one of those is quite expensive to maintain. And the managed Kubernetes offerings, at least the ones that are part of the cloud provider offerings like GCP and EKS and GKE, they still require you to maintain the cluster, right? Like there's still a lot of maintenance work on the cluster itself. The fact that there's definitely a lot of heavy lifting that the providers are doing, but it's still a lot of work for the teams. And so I feel like that's one hidden cost in a way, and I think that using a managed offering that is vendor driven will lock you into that vendor at the cluster level. And so yeah, your Java server, you can take that Java server and put it on a Kubernetes cluster in a different provider, but a lot of the investment that you're making when you're using a managed Kubernetes offering is very specific to EKS or to GKE, and there's a bunch of special capabilities across each one. And so I think like even at that level, the portability notion is kind of not really, it's not the reality. That's what I'm trying to say. I think the other cost here, or the other problem when people choose Kubernetes, when they don't need it, right? Like when people need Kubernetes, I feel I've seen cases where systems leverage the Kubernetes engine as part of the functionality of the system. And Kubernetes has some really amazing, and powerful tools at its core. The reconciliation engine is amazing, and the APIs are amazing. And so if you're building something that's leveraging the Kubernetes capabilities as part of its capabilities, then by all means, that's an amazing tool. And I've seen some really amazing stuff being built with this technology as a building block. But if eventually all you're doing is serving a bunch of HTTP servers, then you're not necessarily getting all that value, and you're actually paying much more in terms of maintenance and complexity. And I feel like that's an interesting trade-off.
we have started talking a lot about developer experience. Of course, developers got lost in a couple of years. We start talking DevOps, DevSecOps. Nobody was talking about developers with the shift left movement. Everything was moving to developers pipeline, whereas there are specialized field securities where networking is there, where you will need specialized folks. What I want to understand is that when we look at Kubernetes and when we look at developer and developer experience, when we look at VMs, when we look at containers, how does Kubernetes fit very well in developers' own way of doing things, their own pipelines? Do they have to go out of their way or things fit into their own workflow? What I'm trying to understand is the struggle, the friction, if there is any.
I think that's a really interesting question, because the way I see it, and one of the reasons Kubernetes is successful, I think, is that I call it, Kubernetes containerizes the developer. And it basically creates a situation where where developers can focus only on a server running inside the cluster, right? Like, and so in most cases, the ownership domain of the developer is this single process, single server running on a machine. And then the platform team, the DevOps engineers, would take this thing and scale it and make sure it, it works, it can be deployed, it can be used in production, blah, 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 blah. And in a way, if you think about it, this is how developers and system administrators have always worked, right? Like, the developers were responsible for the application that's running on the server. And the system administrators, or even before the cloud, the system administrators were responsible for all the non-functional concerns, right? Like deployment, security, compliance, whatever, hardware. And in that sense, I think Kubernetes allowed these two disciplines to continue to operate at the same level. But I think what's happening with the cloud, and that's one of the things that I've been talking about a lot, is that the power of the cloud comes from managed services, in my mind, right? Like, the power of the economies of scale of the cloud come from the fact that I can lean on a managed server and service in order to not do something with my system. And Kubernetes doesn't really play well with this particular aspect of the cloud, because it basically assumes that everything is inside the Kubernetes cluster. It puts the developer inside the container. And so everything that's like outside of their application is not part of their ownership, not part of their responsibility. And what you're seeing is that when you talk to teams that use Kubernetes, usually their footprint, their cloud footprint, is very, very low, right? Like, they would have a Kubernetes cluster, and then they would have like a bucket and a queue. Usually it's like persistent services, like persistent state is usually stored outside of the Kubernetes cluster because it's impossible to manage inside the cluster. It's a suicide mission probably. But usually they use a few, just a few services. And when you talk to teams on the other side of the spectrum, by the way, there's serverless. And in a way, serverless is almost going on the other extreme end of the spectrum, which is also not the right line in my mind, where developers own everything, right? Like in the serverless world, in most cases, there's no platform team, and so developers eventually own their entire stack, and so there are problems with that model as well. But at least in that model, you see the developers are actually leaning more on the cloud. They're making more use of managed services, which in my mind is a good thing. Eventually, it means that they don't have to do certain things. We just talked to this customer today. They have a CloudFormation stack with 495 resources, which is almost the limit. The limit is 500. 495 resources. And that's, this is a startup company. They're doing like lots of async operations activities, processing data, stuff like that. The fact that they're using all these resources, it means that they're not doing a lot of stuff, right? Like, these resources, they add value to their system. And again, I think with both paradigms, both Kubernetes and serverless, this line between the application and platform is not crossed at the right place. feel Kubernetes is too high, serverless is too low. And in a way, this is what we're trying to fix with Wing, right? Like we're basically trying to create a line that allows developers to build and own their cloud application, their entire cloud application, including the cloud resources that are functionally part of their application. But it also allows platform teams to build and own the platform. And the platform is not just the Kubernetes cluster or just a bunch of VMs. The platform is a bunch of resources that are part of their cloud environment. And it's a big challenge. I feel like kind of like redrawing this line is definitely one of the biggest things we're trying to crack.
Can we just boil things down to some of the very basics when we look at developers, what they are trying to achieve? Of course, they're writing business application, they're solving a lot of problems. Of course, we have to talk about the whole sprawl of, security, networking, so that we can look at, hey, this is the right approach. Of course, you can go Kubernetes way, you can go serverless way, but are we thinking about developers? Sometimes what happens, new technologies come and we have to adapt to them. We have to change the way we work for those technologies. But if we just go to the very ground realities of developers, it's hard to say what is the right approach, because it depends from case to case. One company may be doing something totally different, so there's no single answer, but middle ground. So they get to leverage all of these technologies without getting overwhelmed by any of them. Does that question make sense?
Yeah, it makes total sense because this is what we're trying to build. I agree with you. I think the problem today is that we have to commit to a certain runtime technology, deployment and orchestration technology before we started building the application. And that doesn't make any sense to me. When I start to build something, and when companies start to build something, they start simple, right? They start by saying, oh, maybe we'll have like a little HTTP server. It takes requests and stores some stuff in a database. And then a month later, they say, how about we add a little cron job that processes the data in the database and does something? And then a month later, they add another website, static website with a CDN, and they want to deploy that into a CDN. And so now I've used serverless technologies, containerized technologies, and CDN, right? Like 3 types of distribution systems or deployment systems. And today I actually need to completely I have 3 complete separate stacks. We just talked to this customer. They have Vercel for the CDN for the front end. They have serverless stuff for their background jobs, and they have containers for their synchronous APIs. That doesn't make sense. And each one of those is a completely separate development stack, and the developer experience and different tool chain, different CI/CD systems. It's like it doesn't make any sense, right? And so I'm with you, right? Like I feel like what we're trying to do with Wing is basically trying to create like an abstract model. So the model doesn't decide what type of compute platforms you're using or what type of deployment decisions you're making. It basically allows you to express your intent as a developer. You say, I want an API, and I want, this is how I want to react to a get request, and this is how I want to react to a put request, and here's the logic that I want to write for each one of those. And then the decision on how to deploy this is something that you can delay and you can change in the future based on your changing needs. It's exciting. I feel like it's definitely what I would expect as a developer, at least.
Now we talk about what developers need. Can we also talk about what kind of new technologies that you are seeing, new patterns that you're seeing are emerging that might address these pain points?
Everything around infrastructure as code is going in the right direction as far as I'm concerned, because it brings the infrastructure into a programming space. It brings it into a space where we can start manipulating it through code, and that's a great start. I've worked on the CDK at AWS, and this was where we came from, right? Like we said, let's just bring this into the fold, right, of software development, because software development programming languages and software has many tools to model complexity and to manage complexity. You can define interfaces, you can write tests, you can create libraries. There's a bunch of tools that allows you to solve complexity problems. Having those tools doesn't mean that you're actually solving them. I've talked to companies that are using CDK, and I've seen some amazing usage of CDK, and I've seen horrible usage of CDK. But I think at least having those tools is a good start, and I love what Pulumi are doing in this space, and Crossplane are doing in this space. Is basically trying to bring in a lot of the everything into the same model, and so I think that's a great transition. On the other side of the stack, I guess, I'm excited by things like Cycle.io. I don't know if you've seen that, but it's basically basically container orchestration without Kubernetes on VMs. And I really like this because I feel like it's basically, let's take the middleman out, right? Like, it's like, okay, all I want to do is like deploy a bunch of containers on VMs. I don't deploy a bunch of containers on machines. I don't need all this heavy lifting in the middle, right? Like, it's just redundant abstraction in a sense. Again, it doesn't do a lot of things that Kubernetes does, but many people don't need that. And I think on the same space as Fly.io is another good example where you want a container running on the edge. Great, just click a button, you get the container, right? Like, it's super simple, beautiful APIs, and a complex system behind it. It's not a simple system, but so I think from both ends, right? Like, one end is being able to describe systems and manage complexity and create models and reuse and do things on the definition side. I think Wing is coming. Wing is on that on that side of the stack, and then on the bottom side of the stack is, let's see what kind of redundant abstractions we have, and maybe we can avoid them and simplify. I think that's a very natural kind of engineering evolution. I've seen that happen with like many software systems that I've built, where you accumulate more and more and more and more capabilities and features and layers, and then at some point you take a step back and you're like, well, I guess we kind of just like don't need all this part. And then you can like really simplify, and so I feel like it's all a very natural process that we're seeing
In the market, in the ecosystem, whether it's customers, whether it's vendors, are there some trends that you're seeing which are in alignment with your own thought process, with the technologies that you folks are working, where you're seeing, yes, the technologies are being built, but you're also seeing a lot of trends where folks are already embracing some of these practices?
two things that I'm seeing that are aligned with what we're with the way we think about the world. One is realizing more and more that the cloud can use an abstraction layer. Dagger are a good example of that, and I think they're definitely thinking about this in the Kubernetes context. We're thinking about it in a broader context. It's obviously also within the Kubernetes context, but I think this realization that it's valuable to be able to define an abstraction layer for the cloud and build applications on top of that layer. I think there's slowly the industry is realizing that's a powerful transition, and it's interesting to think about it. If we look at what happened with traditional computing and traditional software, this is what happened, right? Like, we've slowly created these abstraction layers so that developers can focus on writing applications, and system administrators can focus on administrating the systems. And I think we're still doing that in the cloud, and I feel we haven't done that yet. We're still not there yet. There's definitely no good standardization, and so I'm excited to see that this is starting to move into that direction. There are a lot of people who think this will never work, right? Like, it's definitely still a very controversial opinion, but the more we are kind of treading to this direction, the more we feel like it's a very, very powerful concept. And so that's one thing. The other thing, which is related, somewhat related, but not directly, is simulation. And one analogy I have that I keep going back to is I used to build aerospace systems. I actually spent some time at Amazon building the drone delivery system, and in my army service spent some time doing stuff like that. And one of the things that when you're an engineer building an aerospace system like a drone or an airplane or a spaceship, is that you're designing that code to run inside a simulator. Because you're not going to fly the plane every time you want to fix a bug, right? Like you have to be able to run your entire system inside a simulator so you can actually develop, right? Develop and test. And I think the cloud is actually one of those engineering domains that actually needs a simulator, but we just didn't realize that yet. And what we're seeing is the exact, like when we started at Prime Air, which is interesting anecdote. The first year we didn't build a simulator. We actually just literally went and flew the drone every time we wanted to test something. We built like these huge flying cages, and it was amazing to see the friction that this creates, obviously, right? Because every time you want to test something, so we had this drone in the lab, and every time you wanted to test your code, you would actually fly the drone in the lab. And I feel like this is what's happening with the cloud. Like literally what we're seeing with people wanting to fix a bug, and they can't run it locally on their machine because they don't have a simulator. And so they have to deploy it into some cloud, some environment, whether it's a staging environment, whether it's the production environment. The number one pain point we hear from customers is quality issues. And that smells exactly like what we've seen in Prime Air, what we've seen, and I've seen in situations where there weren't simulations. And there's a trend starting to happen where teams are realizing that if they were able to simulate their cloud system locally, their velocity and their quality is going to just skyrocket. Pun intended. And there is a bunch of projects like that. Local Stack are good friends of ours, and they're doing something in that space. Being able to like simulate your cloud, emulate your cloud provider basically locally. Wing also has a cloud simulator, which takes a very different approach, but it comes from the same philosophy. And so I think these two trends, and they're complementing, right? Because without abstraction, you can't simulate. And so you need the abstraction in order to simulate. And once you're simulating, it completely changes the game of how you develop. And so, yeah, I'm inviting folks to come check that out. I feel, Wing is not against Kubernetes or anything, right? Like Wing compiles to Kubernetes as well as to serverless, as well as to VMs, as well as to, right? Like there's this decoupling that allows you to build your application, focus on that, and make those decisions later. And so I'm inviting people to come and check it out and play. And it's early days, so we're looking for folks to help shape where this is going.
Lad, thank you so much for taking time out today and share great insights here. Thanks to you. And as usual, I look forward to talk to you again soon. Thank you.
Thanks, man. It's great to be here again.